Welcome to an introduction video for section 5.1, Fundamental Trigonometric Identities. First, we will review some of the identities that we have already seen, and we will also look at the negative angle identities. The reciprocal identities are something we are rather familiar with. We know that tangent and cotangent are reciprocals of each other. Secant and cosine are reciprocal of each other, as well as cosecant and sine. We have seen the quotient identities before, but we can also review them. Let's look at sine of theta divided by cosine of theta and write each of them in terms of x, y, and r. Sine of theta is y over r, whereas cosine of theta is x over r. Multiplying the numerator and the denominator by r cancels out the r, and so we get y over x, which is tangent of theta. Knowing that tangent and cotangent are reciprocals of each other, if tangent of theta is sine over cosine, then cotangent of theta will be cosine theta over sine theta. Now let's look at the Pythagorean identities. One way to look at the Pythagorean identities is from the unit circle. If we consider that any point on our circle is given by xy, or in terms of theta, cosine theta, comma sine theta. The x value gives us cosine and the y value gives us sine, and because we are on the unit circle, r is 1. Using the Pythagorean theorem, we have x squared plus y squared equals 1 squared, or x squared is just the same as cosine of theta. So cosine squared theta, y is the same as sine theta, so plus sine squared theta equals 1. Cosine squared theta plus sine squared theta equals 1 is our primary Pythagorean identity. Now, to get the other Pythagorean identities, all we have to do is take the basic Pythagorean identity and divide each of them by sine squared theta, for example. So divide each of the three terms by sine squared theta. Looking at the first term, we notice both the numerator and the denominator are squared. Therefore, we could rewrite this as cosine of theta divided by sine of theta, all squared. Now we might ask ourselves, if we take any quantity and divide it by itself, what do we get? As long as the denominator is not 0, we get 1. And also, we could rewrite this as 1 over sine of theta, all squared. Now, using our quotient and reciprocal identities, we can rewrite cosine theta divided by sine theta as cotangent theta. So we get cotangent squared theta plus 1, and 1 over sine of theta is the same as cosecant theta, and we'll square that as well. Here we get another of our Pythagorean identities, which states that cotangent squared theta plus 1 equals cosecant squared theta. To derive our third Pythagorean identity, we will go back to our original Pythagorean identity, sine squared theta plus cosine squared theta equals 1. And instead of dividing both sides of the equation by sine squared theta, now we will divide both sides by cosine squared theta. Similarly, we will pull out the squares. Now we will use our reciprocal and quotient identities to rewrite sine of theta divided by cosine of theta as tangent of theta, and 1 divided by cosine of theta as secant theta. Now we have our final Pythagorean identity, tangent squared theta plus 1 equals secant squared theta. Now let's take a look at our negative angle identities. Let's choose an angle, let's say in quadrant 2, not a special angle, just any angle of positive measure, and let's call that theta. So now I want you all to try and draw negative theta. So negative theta will go in the other direction, but the same reference angle. So if theta is in quadrant 2, then negative theta will end up being in quadrant 3. For simplicity, let's look at the unit circle so that our radius is 1. The sine of theta will be the y value for theta. So estimating that to be right about here, the sine of negative theta will be the y value of angle negative theta. We can observe that sine of theta and sine of negative theta will be opposites. One will be positive and the other will be negative. Now let's take a look at cosine of theta and negative theta. Cosine will be the x value. Let's start with negative theta. If we look at the angle negative theta, the cosine of negative theta will just be the x value, which is right about here. Similarly, if we look at cosine of theta, the x value will be the same. So therefore, we get the cosine of negative theta is actually the same exact value as the cosine of theta. Lastly, since tangent of negative theta is sine of negative theta divided by cosine of negative theta, now we can put these two together. Sine of negative theta is negative sine of theta. They will have the same value but opposite signs. But the cosine of negative theta is just the same as cosine of theta. Therefore, tangent of negative theta will be the same as negative tangent theta. Observing on the unit circle, we could see for this example where theta is in quadrant 2, that will have a negative tangent, whereas negative theta is in quadrant 3, which has a positive tangent. So we can see that, in fact, the tangent of theta and the tangent of negative theta will, in fact, have opposite signs. The negative angle identities will be used, but the Pythagorean identities, the quotient identities, and the reciprocal identities are crucial for the rest of this course. In trigonometric identities, theta can be an angle in degrees, a real number, usually radians, or a variable. I hope you enjoyed this introduction.